Solve this inequality. We've got two rational functions. Notice that this one is undefined when x equals 1 or negative 1. That would cause the denominator to equal 0. This one is never undefined using real numbers. So if we cross multiply, there would be x to the fourth plus 1 multiplied with 1 for the left hand side, and then there's going to be x squared multiplied with x squared minus 1 on the right hand side, and then distribute on the right hand side, and we've got x to the fourth minus x squared. And then we'll move all of the terms to the left hand side. The x to the 4 will cancel. The x squared, add it to both sides. And we've got x squared plus 1, negative. Well, I know that a squared number can never be negative, and a plus 1 can never be negative. And so when can the whole expression be negative? Never. So it seems that there's no solution. But of course I should graph it and check. So here's the original inequality, 1 over x squared minus 1, and compare that to x squared over x to the fourth plus 1. And take a look at the graph, and basically we're looking for this first one right here. When is it below this second function? So let me change the window. Here goes the first function, and when is it ever below that second function? The second function is pretty short right here. Let me zoom in on that. So here goes the first function again, and when is it ever below this function? Well, I can see this is part of the first function, and it is below this second function, so no solution is not correct. It looks like between negative 1 and positive 1, the first function does have a branch that's below the other function. So what happened? Well, all of this algebra is correct. This is fine. No solution as far as that. I've got no problem. The problem goes back to what I first pointed out. When is this thing undefined? Or another way to look at it is when I cross multiply, when I multiply an inequality by a positive, that doesn't change the inequality. But if I multiply by a negative, that's going to change the direction of the inequality. So I then have to also consider when is x squared minus 1 negative. So when I multiplied by the x squared minus 1 before, I assumed that it was positive and I didn't change the inequality. So what if x squared minus 1 is negative? Well, I can look at that in a couple of ways. One is graphically. This is a parabola that's been shifted down by 1. So not talking about the original graph, but just the graph of x squared minus 1. A parabola that's been shifted down by 1. And then if I were to find the x-intercepts, solving for x, I would move this over, take the square root, and get plus or minus 1. And then the question is saying, well, when is this parabola below the x-axis? Well, that's in this area down here, between negative 1 and positive 1. So we'd have between negative 1 and positive 1, the parabola is below the x-axis. And now go back to the graph, and when is this function below this function that looks like an m? Well, sure enough, it's between negative 1 and positive 1. And we don't actually include those values because the function is undefined there. But everything between negative 1 and positive 1, the original inequality is true. So use round parentheses Say everything between -1 and +1.